Alright guys, so today we're gonna solve the count vowel string and ranges. This is the day 2 of the leetcode daily challenge, and it's a pretty easy problem if you know how to do it. Otherwise it might just take you a big O of n square if you do it the naive way. I'll be discussing both the solutions and then you can analyze how you can see how the difference is being made. So first let's first try to understand the problem. So basically here what we need to do is we need to find the number of words in this list words for in this range given and how many such words are starting and ending with vowel. So if we take a look at this list, we have words A, B, A, E, C, E, A, and E as words which start and end with vowels, but we need to do the same thing for these ranges. So for 0 and 2 it will be starting from, and since both these two are inclusive, so we need to include the 0 and 2 as well. So in the case of 0 2 it will be 0 1 2, 1 4 it will be 1 2 3 4, and for 1 1 it will be just this. So that's why you see why for 1 and 1 we get 0, because BCB doesn't have any vowel starting or ending. For 1 and 4 it's 1 2 3 and 4. So out of these 4 words only EC, AA and EE are the ones which have vowels in it starting and ending, so 3. And for 0 and 2 it's ABA and ECE. So let's try to solve it first using the naive way, and we'll see how it's gonna be a TLE. So for that I need first a set which has all the vowels in it. Now that we have it, we can iterate for each of these queries. We'll get a list of words, and that will be from words starting from I including J, so it's a J plus 1. Now for each of these words we need to check if the starting and ending are vowel. So basically we can get the index -1 will be the last index. So this is the condition where both the starting and ending for each of this word in this list that we are getting from these ranges, is it in this set or not. So basically this list one that we are seeing here will be nothing but a list like, for example, in the first query 0 to 2 it will be a list like ABA, BCB and ECE, so on and so forth. It will be like that, and we have word 0. So if this is the case, then we just need to increase the count. We can define the count variable exactly here. We need a new count variable for each query, so I'm defining it here, and once we get that, let's declare another list which will have the result in it, and we can append the value of count in it, and then we just return this res. So it's gonna pass the test case, both the test cases, but it will be a TLE. Alright, set 1. As you can see, it's passing both the test cases, but if I try to summate it, it will be a TLE, because this is basically a O n square solution, big O of n square. I'll tell you why. There are 2 for loops here, so, and both the queries and the subset that we are getting, the sublist which we are getting from the original one is basically too long. As you can see in the description, both of them go for up till 10 to the power 5, so it's not a good solution. To optimize this, we'll use something called as prefix sums. So we need to first understand that in this list words, with each passing index, how many words we did, how many words we found with each passing index which start and end with the vowel. So basically we draw it here. So we'll take the first example. The first example is ABA BCB, this one. So in the first example we see that we have ABA and then BCB, ECE, AA and E. So our first step is to understand by each passing index how many words we encountered which are both starting and ending with a vowel. So when we approach 0th index, it's one word which has both starting and ending as vowel. We come to BCB, it's still one word because BCB doesn't have that. With EC we encounter one more, so it's 2 now. With A and A it's 3 now, and with E it's 4 now. So we encountered 4 vowels as of now, 4 words which meet the condition. Now since we have this, we can use this value right here, this list of values right here, to find exactly like which words from this range satisfy the condition. How many of them? We can get the count directly by just subtracting the bit from this range to this range. So basically what I'm trying to say is, from index 0 to 2 we need to look here, and to get that we just need to get the difference of these two values. So it's going to be 2 minus the value just before this index, since it's already at the last index, so we'll just minus 0, so this will be 2. For the query 1 to 4 we need to subtract the value at index 4 and the value at the value just before the index at 1. So in this case it will be 4 minus 1, which is equal to 3. And for the last one, which is 1 to 1, we basically need to take the query 1 and the index just before it, which is 0, which is 1. So it's 1 minus 1, which is 0. So that's why we get the final answer as 2, 3, 0. So if we try this approach, it will be a linear solution, because in first step we are going to find the prefix kind of list here, and we'll have all these values, which is basically the count of words which satisfy the condition, first and last characters as vowels. And once we have that, we can simply subtract the index. So this will basically be the j and I minus 1. The reason we are doing I minus 1 is because that's how prefix sums work, and we'll get the range, all the values which are actually satisfying the range. So yeah, that's how the linear solution works. We can now try to code this up, and I'll show you how we are doing that according to the diagram. So let me just put it here. Alright, so first step is to find the prefix sum, and let me just reset this. So for the prefix sum, I'm just defining a list which is going to have all the prefix sum values, and we'll be doing that using the words list here. So we're going to iterate the words list. And then we'll also need the set, which had all the vowel characters in it. So for each word, and then the count as well. So basically first we need a list which is going to represent if each of these words in this initial words list is a vowel or not. So we will do that using binary ones and zeros. That's when we'll get the final count, which I said here. So basically what I'm saying is, to get the prefix sum list, this A, B, A, B, C, I'm gonna replace that with a binary list. So since A, B, A does satisfy the condition, I'm gonna replace it with 1. B, C, B does not, so it's gonna be 0. E, C does satisfy, it's gonna be 1. A also, and so does E. This is what we're gonna start with, and then we'll find the prefix sum of on this list. So we'll start from the 0th index. It's gonna be 1, 1, 2, 3, 4. Now this is the same list that we got here. This is how we are finding the prefix for each of these for this list. So that's where I'm trying to, well, that's what I'm trying to do this. So this list 1 is basically our this list initially. So to have that, I'll have to check the condition, the first char and the last. If they are both in set 1, then we're gonna append 1 in it, else it's gonna be a 0. Now we have this. Now we need to get the prefix sum. There's a quick way to do it. We can modify the same list that we just got now, and we can do that. So for that, we're gonna start from the first index, and then in that index we're gonna add the value of the previous one. So we are gonna start with 1. We're gonna leave 1 index, 0th index as it is, because that's the prefix for that. We're gonna leave it as it is. But for the first index, we're gonna add the value of this with the -1 of it. So it's 1, so it's 0 and then plus 1. So now it's 1. And then we go on the next one, it's 1, this index minus the new value of this index, which is now 1. So it's 1 plus 1, 2. It's basically this operation going on, 2. And then we add it again, 3. We add it again, and that's how we are getting 4. So to kind of not create another list for that, we can just do this all the way to the last of list 1. List 1 R becomes now we have this list. I can show it to you. Like this is what we are getting. It's gonna be 1 1 2 3 4. I can show. For the first case at least, it's gonna be that. So 1 1 2 3 4. Now that we have the prefix kind of prefix sum list with us, we can just perform the difference for each of the query. So this is a ON operation in its own, and the next step that we're going to do will be on this list 1 and still be a ON operation. So overall it's going to be an O of n solution. To return the final result, I'm going to define a result here, and we can simply now run the query on this list 1. So we're going to declare a variable res which is going to store the value, and it will be the difference. So list 1 j minus list 1 I. This will hold only if I minus 1, because we need to include I. This will hold only if I minus 1 is greater than or equal to 0, because if it goes beyond, if it goes before like way less than that, like which will be minus, then we have to completely ignore it and just put in list 1 of j, which we saw in the first case, which was from 0 to 2, because 0 minus 1 is giving us -1. So we don't want that. We just will take values up till 2, and then we are going to append this value in our result list, which we declared up, and we just need to return this now. So this is a more optimized solution, which is of a big O of n. Both conditions, both test case getting passed. Now let's try to run it. And see, it works pretty fine, 27 milliseconds, and yeah. So this is how you solve it in big O of n and try to reduce the time complexity from n squared to n. You separate it into 2, and this is where prefix sums come in useful. whenever there's a range asked, you should always focus on getting a prefix sums, because that's when the prefix sum kind of shines. If you like this video, please try subscribing, and more solutions coming on the way. I'll see you guys later. Bye.